Hi, welcome to ISE503. This chapter is the part 2 of Fundamental Concepts of Database Management. So let's start with the definition of database. In the first part of this chapter, I missed this definition. So here we go. There are multiple definitions of database possible, but let's look at this definition of database. Here, a database can be defined as collection of related data items within a specific business process or problem setting. So let me point out few key things here in the definition. When we define database, then it deals with the data items which are related. So this related is an important notion over here. So in a database, we will have the data items which are related. And then the other important aspect here in the definition is that they are related with a specific business process or problem setting. For an example, let's think about a database of purchase order, which we can write in short as PO. Now, in the purchase order database scenario, we can think of products which are being purchased, and these products would be supplied by a supplier or a seller, and then they will have the relationship. The product will have the relationship with the supplier, and then for that relationship we may need a relation in itself which may be called as purchase order. So this will take more concrete shape when we start our discussion in detail in the next few chapters. But this definition, this example is important. Why? Because here the database that we are looking at is the purchase order database. Therefore, it has a specific business process in the definition involved. And let's move on to the next bullet, which says that for a database, it has a target group of user and application. So for the same example, purchase order, let's think about the target group. So this purchase order database could be of use to an inventory manager or a purchase order manager as well. So these things are important in understanding the definition of database. Alright, so once we understood what database is, let's move on to the next important definition in ISE 503. It's the database management system, or in short you can call it DBMS. What is it? So DBMS is a software so you can either call it a software or software package which is used to define, create, use and maintain a database. So this software which is called DBMS is a complex software. So in fact this whole course will try to understand to some extent the importance of DBMS in computer science. So what it does, it's a software which is a complex software. It has a number of modules. So the next bullet talks about that. It consists of several software modules. So for what are these modules and all, what is their role, you don't have to wait much. The next chapter will talk about it. We'll discuss in detail the different components or the different modules of a DBMS and their role. But anyway, what will this software do for us? It's a software package that is used to define the database, to create a database, and use and maintain the database. And one more time, it has several software modules to take care of these responsibilities. Okay, let's move on to the third definition. This third definition is about database system. What is a database system? So the combination of DBMS, which is database management system, and the database that this DBMS is managing is together called as database system. So the combination of a DBMS and a database is often called database system. Now, let's look at the different kinds of users who interact with a DBMS or database. Let's call it database only. So there are different kinds of users who can interact with the database. So let's start with the first class of user. They're called information architect. We did discuss about information architect in the beginning of the previous lecture. So what is the role of an information architect? So information architect designs the conceptual data model. So there are different kinds of data models. We have conceptual data model, we have logical data model, internal data model, as well as external data model. Now this conceptual data model is an extremely important data model because I believe from that stage, from the conceptual data model, the actual database design starts. And this conceptual data model is built by the information architect as the information architect interacts with the business user. So let's think about an example, the same example that we had, a simpler one, the purchase order database. Let's say that we have to build a purchase order database. Now for that, we will have some client. The client could be the shop owner and or a store owner. Let's think that the store owner wants a database for the products that the store owner is selling. And if you want to build the database for that shop owner, then yeah, you need to reach out to the shop owner. You want to identify the requirement of the shop owner so that you could design the database for that fellow. Now now in your organization, you'll have an information architect. The information architect will reach out to the business owner or the business user here, who is our shop owner. And the information architect will meet the business user or the shop owner and will try to identify the requirements, and those requirements are modeled in conceptual data model. And we learned about the role of conceptual data model, why is it important and all. But yes, the information architect is the user or the database user, you may call it, who would do this thing, who design the conceptual data model, but that design will have on the basis of the interaction of the information architect with the business user. Now the next important user is your database designer. Now what is the role of database designer? Well, this database designer will take the conceptual data. So let me read this first and then I'll explain that. Database designer translates the conceptual data model into a logical and internal data model. So once we understand the requirements of the business user, we need to ultimately implement that. We need to have the system ready. But for that ultimate implementation, it has to go through different stages of the translation. So the next stage that comes is handled by a database designer, who take the conceptual data model and will translate that conceptual data model into the next the level of models, which are logical and internal data model. All right, let's move on and see who is the next user. Then comes the database administrator. Now DBA in short, or database administrator or DBA in short, is responsible for implementing the database and monitoring the performance of the database. So this is important. The role of DBA is extremely important, although that is when we are discussing about DBA as the third user, but that doesn't mean that it is anyway less important. I would consider, it's my view, I think that DBA is the most responsible user in the database. Okay, so what a DBA does, what database administrator does. The DBA is responsible for implementing and monitoring the database. Now finally we have the application developer. I should not say finally because I think there is one more category that will be the last, but here in this bullet we are looking at the application developer. Now application developer, what the application developer will do, sorry about that. Application developer develops the database application in a programming language such as Java or Python. Now, in the database context, in some of the tags, you may find the term like host programming language mentioned. Host programming language. So, in that context, host programming language refers to the high-level programming languages like Java or Python, which may be used in developing the actual application. Okay, another question arises: why was a host programming language needed? Is the DBMS enough? I'll say probably not, because the kind of flexibility that we get in these languages like Java and Python, their control structures, their conditional statements, their iterations, the other features like maybe object-oriented feature that you may want to use. So that kind of flexibility is available in high-level programming languages or the host programming languages. So the application developer would develop the whole application in the languages like Java, Python, or similar languages. But in that application, they will interact with the database using the DBMS query languages or the interfaces. We'll discuss about that soon. Now, the next class of user is the business user. Who is the business user? The business user will run these applications to perform the specific database operations. So in my example of the purchase order database, I said that let's think about this purchase order database which we are building for shop owner. Sorry, my bad. Shop owner is what I want to say. So the shop owner is the business user over here, and the business user will pay for this product that we are developing. The product means that the database application that we are designing for the shop owner, so that the shop owner could use this database application or our product to manage the products that the or the inventory, we may call it, that this shop owner is managing. All right, so now let's move on to the different languages that a DBMS might provide. So database languages, or you may call that database management languages, DBMS languages. So here, let's look at the first class of language which a typical DBMS system must provide. This is called data definition language, or in short you may call it DDL. Now this DDL that we have is used by DBA, which is our database administrator, to express the database external, logical, and internal data models. What are these? We have already discussed the data models. So there are different kinds of data models: conceptual, then we have logical, then there's internal as well as external. So out of these data models, the data definition language has the facility of expressing what? The external data model, the logical data model, as well as the internal data model. Therefore, the DBA, which is the database administrator, will use DDL, the data definition language, to create or express the external, logical, as well as internal data model. Now, question arises, where are these stored? Now, these definitions which a DBA will be providing for the external data model, the logical as well as internal data model. These definitions are going to be stored in the catalog. What's the catalog? We learned about it in the previous lecture. It's the heart of DBMS. Okay, and where we keep the important data definitions, or the metadata you may call it. Now let's look into the next category of the language in databases, which is called data manipulation language, data definition language versus data manipulation language, DDL versus DML. So data manipulation language is used to retrieve, insert, delete and modify the data. So once our data definition is provided by DDL, or data definition is a term that I'm using for all these different models, external, logical and internal data models. Then yeah, we need to populate the data. Okay, populate the data means inserting the data into different database objects. So once the data is there, now you may like to play with the data. So you may like to retrieve the data, you may like to insert more records into your database, you may like to delete some records or modify the data. So these are some common operations that the user may perform on the database. So in order to facilitate these operations, retrieval, insertion, deletion, and modification, we would use the DML, which is data manipulation language. Now DML statements can be either embedded in a programming language or can be entered interactively through the front-end querying tool. So these are the interfaces. It all depends on the kind of interfaces which are being provided by a DBMS. So these are very common, and as I mentioned to you in the previous slide, that when the application developer is developing the application in the host language or the high level language, then the database part would involve the use of the query language provided by the DBMS. Okay, so here now we are getting more information. The application developer may use the DML statements, data manipulation language statements, embedded inside the programming language to access the data from the database. Now, one good news is that the most popular, I'm confident about it. I should have done the homework though, but I'll rely on my confidence. I believe that the SQL or structured query language is probably the most popular language in DBMS. Okay, when I'm saying DBMS, I am keeping the most recent database management systems, which are NoSQL database management system. All right. So yeah, SQL, structured query language, which relates to relational databases. The good news is that SQL offers both the data definition language as well as DML. Excuse me. And the one of the main reasons behind the dominance of relational database has been its query language, which is SQL. Okay, good. So we have it here. The SQL, which is structured query language, people also call that SQL, offers both DDL as well as DML statements for relational database management. Okay, so now let's look at the advantages of database systems and the database management. We will first list some advantages and then we will dive a little deeper into these advantages. So the first advantage that we have is data independence, then comes database modeling, followed by the facility of managing structured, semi-structured and unstructured data, managing data redundancy, specifying integrity rules, managing concurrency control, taking the responsibility of backup and recovery, or providing backup and recovery facilities, data security, performance utilities. So yeah, you should know these advantages. Somebody may ask you a list few advantages, or like list 5 advantages of database systems or DBMS. So now let's look at these things, like what do we mean by data independence. So let me read this first and then I'll provide you more explanations. Data independence implies that the changes in the data definitions have minimal to no impact in the application. So the data independence, we will discuss about two data independence: physical data independence and logical data independence. Once I explain those things to you, then you will be in a better situation to understand what is this data independence in general. Excuse me. So let's start with the physical data independence. What do we mean by physical data independence? Physical data independence. Now, these concepts that we have, this concept rather of data independence can be better understood if we keep that three schema architecture in mind. So what I'll do after this slide, I'll take you to the next picture that I have. So in fact, let me do that right now. Okay, wait a second. I think I missed that picture. I could not save, but that picture is already there in your previous lecture, three schema architecture. So what is physical data independence? Physical data independence implies that neither the application nor the view or the logical data model must be changed when the changes are made to the data storage specification or the internal data model. Now, we have different data models already seen, already discussed a little bit about those. So in reality, the data is stored is stored as specified by internal data model, where the data is stored in bits and bytes on the physical storage media, where we need to have the understanding of the different the file organizations, right? But in order to facilitate this whole database management, or efficient data storage, retrieval, maintenance, and all, the DBMS has given us the different data models. Okay, conceptual data model, the logical data model, then internal data model, external data model. Now with these facilities, different levels of data models, we have these independence possible. So that's what we are discussing right here. So physical data independence says that the changes that we are making, where are we making the changes? The changes that are made to the data storage specification, which means the changes that you are making at the internal data model, right? So let's think about some efficient file structure that you could think of, right? Or you thought about some uh, indices or indexes to be introduced, right? Just to improve the performance. Now those changes are happening at the internal data level. So these changes should not impact the application that has been written, the database application that has been written. Okay, and it happens, and which is very good news. Now the question arises, how was that flexibility possible? So that flexibility was possible because of the concept of physical data independence, which says that neither the application needs to be changed nor the view. What is the view? View is a part of external data model. Okay, you don't need to change the database application, which may interact with views, okay, or the external data model. So you don't need to change that. You don't even need to change the logical data model, right? Because the changes are actually happening at the internal data model. So this is a great flexibility. Okay, and how is that possible? That is possible because of this concept of physical data independence. Okay, so who has taken this responsibility? DBMS has taken that. Okay, the DBMS software package. DBMS is a software package with different components that helps us in creating. Sorry, we should start with definition that helps us in defining, creating, and using, maintaining database. So DBMS should provide the interface between the logical and internal data model. It's an important thing to remember. So in fact, I should put the stars over here at the top to give you the hint that data independence is an extremely important topic. So much so that probably I already mentioned that three-level architecture or three-schema architecture is a very important concept in database management. Now let's move on to the next class of data independence, which we call as logical data independence. So what is that? So the logical data independence implies that the software applications are minimally affected by the changes in the conceptual or logical data model. Okay, so in the previous case, which is the physical data independence, we discussed the changes which are happening at the internal data model. So those changes should not impact the database application, the views, or the conceptual model. We've seen that. Now, in the logical data independence means that the software application or the database application, you should say, should be minimally affected if the changes are made at the conceptual or the logical data model. Okay, so which is again a flexibility. And now how can that be achieved? In this case, the views in the external data model will be very important for us. Why? Because they will behave as the protective shield. Right? Again, a very important information about the views which are the part of our external data model. Now, views in the external data model will act as the protective shield for the logical data independence. And here again, this is the responsibility of the DBMS to provide the interface between conceptual, logical, and the external layer. Okay, so between these layers, we should have this mapping. So again, I apologize. I had put this picture, that three schema architecture picture from the previous lecture, but I messed it up. I could not save that. So I'll request you to go back and look at that picture, because in that picture we are talking about this mapping which DBMS provides us, or the interface that the DBMS provides us for physical data independence and the logical data independence. Now let's move on to database modeling. So what is a database model? What's the role of a database model? So database model is an explicit representation of data items together with their characteristics and the relationship. That's the purpose of database model. There's not much to explain, so I won't attempt that. It's a simple statement. Please remember that. So in the database model, we did discuss about a conceptual data model. What is the purpose of conceptual data model? It should provide a formal and perfect mapping of the data requirement of the business process, and it is made in collaboration with the business user, right? So kind of discussed it when I was introducing you to the different kinds of user or different class of user of the database. So in that context, I did discuss about the database, the end user, and the information architect. the very first class of the use. So the conceptual data model should do that, should provide a formal and a perfect mapping of the data requirements of the business process, and it is made in collaboration with the business user. And it is translated into logical and internal data model. Then uh, about the conceptual data model, the conceptual data model is not stored in the catalog. Therefore, it is important that the data models here, here it is more about the conceptual data model, and it can be applicable to other data models as well. It is not always possible to have everything included in catalog, right? There are some information which we cannot provide in the catalog, right? Therefore, it is important that a data model's assumptions and the shortcomings are clearly documented. Documented means something which is not going in catalog. So it should be documented for later references. Now let's look at different kinds of data that we can have in our database. So the structured data, I would say initially, when I'm saying initially, I'm referring to the data of which was in which was used. I mean, structured data is used even today, but I'll say the most of the data, probably some 20-30 years back, was of this kind. But now we have the data which is not structured, right? Unstructured data. So that's what I'm trying to communicate. Structured data is probably the most common data, the simplest data to manage. I'll tell you why is that simplest. So, whereas the unstructured data is more complex to manage. But good news is the DBMS that we have these days, they are capable of managing structured data and unstructured data. These are two extremes. Structured I'll consider the most well-behaved, unstructured more tricky, and then we have something in between these two extremes that is called semi-structured data. So in structured data, what is that? The advantage of structured data is that it can be described according to formal logical data model. So as an example, let's think about a record that we are maintaining for a student. And for student record, we can think of these attributes or these properties of a student, like the student's ID number, the name of the student, the address of the student, email of the student. Okay, so in the structured data, we would know the structure of the record. We would know that the first information that we would get would be the student ID number, which would be an integer value. Then the name would be the string of characters. The address would again be string of character, and we can decide like what should be the maximum size of a name, say 30 characters long. Then the address is again going to be a string of characters, and we can probably determine the size. Address could be say 50 characters long. If you want, you can put more characters there. Then we know the email should have a certain format. And once we understand about the structure of an email, then yeah, we can make that to define something called as integrity rules. We will look at integrity rules soon. The purpose of the integrity rules is to make sure that the data is correct. When we are inserting the data in our database, we want to make sure that the data is correct, and that is enforced using the integrity rules. So back to the first point over here about structured data. It can be described according to a formal logical data models. When we will learn about tables, we will do that for relational databases. We define tables. So in the table definition, we do provide the information or the definition that the number is going to be integer, name is going to be string, address is again a string, email is again a string. Okay, now because of that, we have the ability to express the integrity rules, right? That's what I was mentioning. Integrity rules are there in place to enforce that the data correctness is maintained. The ability to express integrity rules and enforce the correctness of data. Okay, integrity rules are there to enforce the correctness of your data, and it also facilitates searching, processing, and analyzing the data, right? So it's a very common phrase which says that the necessity is the mother of invention. I hope I correctly remember that. So probably earlier we did not deal with the unstructured data that much, but today we have a lot of unstructured data. Okay, so because of the volume of unstructured data, which is clearly by many magnitude, um, what I should say, has dominated the structured data, outvolumed, I should say, right? So let me rephrase it. The unstructured data that we have today has outvolumed, right, the structured data. So because of which we have the databases like NoSQL databases. Earlier we did not have much of unstructured data, right? But we still have structured data, right? So right now we are looking at structured data. Now, with the structured data, we have this facility that you can efficiently search, process, and analyze the data. So if you have stored this structured data with the fields like name, now student number, student name, address, email. Now with that, searching the student who stays in New York is very easy. You can write a simple query and can get that data. But now let's look at the unstructured data. How is the unstructured data so challenging? In structured data, we had the fine control, right? Fine-grained components. But here, you don't have any fine-grained component in this unstructured data. Let's take an example of a file. Okay, so we can think of a file. Wait a second, right? This is what I'm referring to. In order to understand unstructured data, we'll take an example. But I think first I should read these bullets and then I'll explain to you. In unstructured data, we have no finer grained component in file or series of characters that can be interpreted in a meaningful way by a DBMS or an application. All right. So in case of the structured data, as I was mentioning to you, we can make use of the logical model to provide the data definition, like the first field being number, which is an integer, the second field being the name, which is string, so on and so forth, right? That is defined when you're creating your table, as an example, in relational databases. In unstructured data, you don't have that kind of control. So let's think about an example. If you have a file or a document with biographies of famous New York citizens, okay? Now, if you are provided that huge file with the biographies of famous New York citizens and you are asked the same question, now from this file that has the information about famous New York citizens, find out those who studied in New York. Right now, well, you can write a complex program and you will succeed in finding out the name of these people, right? And then probably you would be able to find out New York there in the document. But the tricky part is that these people and the New York can be related in multiple ways. Some people may have been born in New York, but they did not go to school in New York. And the other people, well, if it's written somewhere, right, like they prefer the shirt with the New York written in there. So what I'm trying to communicate is that here the life is going to be complex compared to structured data. Why? Because we don't have, there's no finer grained components right, in a file or a series of characters that can be interpreted in meaningful way by DBMS, as was possible in structured data. Now, an interesting information is that the volume of unstructured data has surpassed that of the structured data as I talk. All right, and I expect the same trend to continue in the decades to come. Interestingly, we have the third category, which is sitting in between the first two categories. This is this semi-structured data. So in semi-structured data, we do have some structure, but that structure is highly volatile. So the data which does not have a certain structure, but the structure may be very irregular or highly volatile. Let's look at some examples of semi-structured data. So let's say we have the individual user's web page on some social media platform. It will have some structure. Or if you're looking at the resume documents of the applicants in the HR department. Okay, so now let's look at the other advantages of database or database management. Managing data redundancy. So data redundancy is something that we would try to avoid, and redundancy is a bad news, but sometimes the redundancy is important for us. Okay, and we may introduce redundancy for the sake of efficiency. So let me look into that, and then I'll explain to you why we would need redundancy. Duplication of the data can be desired in distributed environment. Okay, so the redundancy we may introduce in our database, that will probably have to do if we have the distributed infrastructure. Okay, where our data is not confined to say one location. If we are a global enterprise, just think about the apps like Amazon, right? They have so many data centers, so the data is redundant there. So we would like to duplicate the data in the distributed environment. And why should we do that? Just to improve the retrieval process. Okay, so we want to give the better user experience to the end user, and we don't want to introduce the latency or the delay. Very soon you will look I'll talk about the KPIs, and then latency is one of the KPI over there. So by introducing more redundancy, we can reduce the delay, and we can also save cost of the network infrastructure. All right, so if we are thinking of improving the efficiency by introducing redundancy, then yeah, we should manage the redundancy just to make sure that data is consistent. Redundancy would impose a problem, that will be inconsistency. Therefore, the DBMS is now responsible for management of the redundancy by providing synchronization, which will help us in data consistency. Now, compared to the file-based approach, the DBMS guarantees the correctness of the data without user intervention. That's a great news. Now let's look at the integrity rules. All right, so if you remember, I did mention about integrity rules when we were discussing, or when I was discussing rather, when I was explaining to you the different kinds of data. Structured data, right? With structured data, using the logical data model, we can enforce the correctness of data using integrity rules. So let's see what are these. Now, the integrity rules can be classified into syntactical rules. So let's look at that. Syntactical integrity rules specify how data should be represented and stored. Very simple. Okay, so let's look at an example. The customer ID can be an integer. The birth date can be stored into 3 fields, as a month field, which could be integer or string, it all depends. Day and year. Day and year must be an integer. Alright, so that those rows which will determine the syntax of the data would be in syntactical rule. Now, interestingly, we have another class of integrated rule, which is called semantic rule. Semantic rules are those rules which cannot be enforced by syntactic rules. Semantic means something that relates to the meaning. Okay, and it is more specific to the domain. So semantic rules, they come from the domain. So let's look at some example. Semantic rules, first of all definition and then the example. Semantic rules focus on the semantical correctness or the meaning of the data. Example, the customer ID should be unique, right? So this uniqueness is not specified in the syntactical rule. It will come in the semantical rule. In syntactical rule, we'll say, okay, yeah, customer ID should be an integer. But the semantic we would impose by enforcing that it should be unique. We can't allow two customers with the same customer ID. The second example is even more interesting. The account balance should be greater than 0. Okay, and the customer cannot be deleted if he or she has pending invoices. All right, interesting examples. Now, the integrity rules are specified as the part of the conceptual or the logical data model and is stored in the catalog. This is an important information that you should remember. What is it? The integrity rules, they are stored in the catalog, and that is how it is directly enforced by DBMS instance instead of the application, which is a flexibility. Yeah, I'm using the term flexibility, but you can consider that as one of the key advantage of DBMS, which is the fact that the integrity rules can be defined, and these integrity rules can be syntactical or semantical, and so much so that they can also be stored in the catalog so that DBMS can enforce those, and the application programs or database applications are relieved from this responsibility. Now let's move on to even more important concept, which is concurrency control. So DBMS has inbuilt facility to support concurrent or parallel execution of database program. Now, well, gone are the days when we'll think about just one user using the database at a time. Okay, we need to support multiple transactions happening at the same time. Transactions means the users making use of the database. Here I'm not using the technical transaction thing, the technical transaction concept in database. At this point, when I'm saying transaction, I'm referring to the layman term transaction. So DBMS should provide the support for concurrent or the parallel execution of database program. Multiple transactions, maybe hundreds, thousands, or even more. Now, the key concept is a database transaction, right? Here we go. You can't avoid database transaction, which is very, very important. But what is it? That definition is coming later. So a key concept is the database transaction. Database transaction when we are providing the concurrent access to the database by multiple users. So the sequence of read and write, it will happen. A sequence of read and write operation is considered to be an atomic unit in the sense that either all the operations are executed or none at all. So that's that is at a very high level one of the way in which we guarantee the concurrency control. Now the read and write operations can be executed at the same time by the DBMS, and the DBMS should avoid inconsistencies, right? So a big responsibility on database management system. What is it? Well, in order to enforce better efficiency in the sense of providing multiple customers accessing the data at the same time, parallelly or concurrently. Inconsistencies may happen if you don't have any measures for concurrency control. So let's look at the problem that might arise if you don't enforce the concurrency control. So here in this picture over here, we are taking a very simple scenario involving two transactions T1 and T2, and we want them to happen concurrently. And how's that happening? Well, in the first column, which is time, you can see T1, T2, T3, T4, T5 and T6. These are different timestamps, and then these are the transactions happening T1 and T2. They are concurrent. How come? Well, look at the time T2. At the timestamp T2, both the transactions are happening. Transaction T1 just began, so at T2 we say begin transaction, whereas the transaction T2 is already in the second phase, which is reading the data. All right, so if we could just think about T1 as if T2 was not present, then what is happening? Let's ignore T2 for the time being. The T2 means the T2 transaction. So for T1, what is happening? You will read the transaction at T2, time T2. The balance was 100. You begin the transaction at T2. At T3, you read the balance, which was 100. Then in transaction T1, we are taking $50 off. We are debiting the account. So because of which the balance will be balance minus 50, right? So if you could do the basic math, then the balance should remain 100 minus 50, which is 50. And in T5, you will write that balance and it should be 50 and end the transaction, right? So that is what will happen if you have only one transaction T1. If you have transaction T2, let's ignore T1 for the time being. You'll begin the transaction in T1 and in T2 you will read, and on reading you'll find that the balance is $100. You want to put $120. You want to credit your account. So by crediting, your balance will be 120, which is 220. Okay, and you will write the balance to 120 and done. Right. So if the transactions T1 and T2 they are happening sequentially, means not concurrently, not parallel, then the life would be good. Right. Very simple. Nothing to worry about. But when we are providing the concurrent control, then let's see what will happen. Both these transactions are happening in parallel, concurrent. At T1, luckily, at the time T1 transaction did not start. Only T2 started transaction, begin transaction. At T2, T1 also started. So T1 transaction is at time T2 saying begin transaction, whereas the transaction T2 is reading the balance. At the time T3, T1 now started reading, okay, and the balance that T3 read, transaction T1 read at time T3, it is $100. All right, and at the timestamp T3, the balance that T2 is maintaining in its local memory, right, would be 100 plus 120, which is 220. All right, so transaction T2 has maintained the variable balance with the value 220. Okay, and in the timestamp T4, transaction T1 will compute the balance, and for T1 it will be 100 minus 50, which is 50. Whereas what transaction T2 will do, transaction T2 will now write the balance 200 in that, the actual balance thing, right, which is 220. So the actual balance has been updated to 220 by transaction T2. But look at transaction T1. Transaction T1 is working on its local copy of the balance, which is now 50. Okay, and then at the time T5, what happened? the transaction T2 terminated. It's done. And at T5, transaction T1 will attempt to write the balance value, which is 550, to the actual balance thing, right? The shared variable or the global variable. And what it will end up doing is that the transaction T1 will uh, overwrite the value 220 with the value 50. Okay, and the end result is 50, which is not correct, right? So this is a problem actually which has happened because of the uncontrolled concurrency. Okay, we provided the concurrent execution, but it was not synchronized. So something that should have been 220 minus 50, probably 170, is 50. Okay, so that yeah, so it's not correct. This is a problem which is called the lost update problem. Someone might ask you, what is lost update problem and when will that happen? So you should be smart. You should be smart enough. You should say, okay, the lost update problem may arise if you don't have proper concurrency control. All right, let's move on. Now, the DBMS must provide ACID. It's again a very important concept. All right, that relates to the transactions. Now, I'm referring to the technical transaction that we use in the databases. So it's a common question like define transactions in database. So transaction is a special program that enforce the ACID properties. All right, what is this ACID? Here A stands for atomicity, C stands for consistency, I is for isolation, and D is for durability. So transaction for us is going to be a program which should satisfy these requirements, these properties, acid properties, atomicity, consistency, isolation, and durability. So what is atomicity? Atomicity requires that a transaction should either be executed in its entirety or not at all. That's atomic. Consistency ensures that the transaction brings the database from one consistent state to another consistent state. We cannot allow a transaction to happen which will take us from a consistent state to an inconsistent state. No. Now, if you're worried about how the consistency would be checked, well, we will make sure that our data is correct. And so consistent state should have the correct data. Now question arises, how do we check the correctness of data? For that we have integrity rules. What is isolation? The isolation property ensures that the effect of the concurrent transactions should be the same as if they would have been executed in isolation, right? So in isolation we won't have any problem. So yeah, the nature of the concurrent execution should be similar to the isolation execution in isolation as per the consistency. It doesn't say that efficiency wise. No, efficiency wise the concurrent execution should be faster, but yeah, consistency wise it should end up with the same result as the isolation operations. Isolated execution, I should say. Durability. What is durability? Durability means that, or should ensure that, the database changes made by transaction which are successful should be made permanent in all the circumstances. So guys, make sure that you understand asset really well. Really well means the content which are there in this lecture slide. Yeah, we can discuss in more details probably later, but at this level you should know about these four properties and one liner definition of your understanding about all these properties. Now let's move on to the next advantage of the DBMS, backup and recovery. Fairly simple. So backup and recovery facilities can be used if those are provided by the DBMS to deal with if any effect of loss of data, and the loss of the data could happen for many reasons. It could be due to the hardware failure, or it could be because of the network failures or errors, or it could be because of the bugs also. Alright, so the backup and recovery facilities can be used to deal with the effects of loss of data due to hardware or network errors or bugs in the system or application software. Now, with the backup facilities, you can either perform full backup or incremental backup. It all depends on the situation you're facing. Well, we should have the recovery facilities also. Recovery facilities will allow you to restore to the data restore the data to a previous state after the loss has occurred. You want to recover the previous stage. Data security is again a very important feature that the database management system should provide, or database management should provide, DBMS should provide. And good news is that they enforce, right? Security can be enforced by DBMS. And how? At a very high level, it can be controlled by restricting the access to the user. Some users can have only the read access, whereas the other users can request and may be granted the write access. So it all depends on the role. Okay, so we have an interesting example about the vendor management in inventory. So let's think about an inventory system which is taking stock of the products which are available in our inventory. Now we can think about this inventory management system which can be managed by vendors, so that the vendor could look at the status of the product in the inventory, and if required can order fresh stock. Okay, and yeah, can update the inventory. Now here we should be very careful in providing the access. So well, we'll have multiple vendors and some of the vendors might be competing. Okay, so when we have the competing vendors, we'll have to respect some privacy, right? Some data of one vendor should not be made available to the other vendor, because the other vendor may use that unfairly for business advantage. So yeah, we should be careful, and that is possible with the help of the features which are provided by DBMS, which falls in the category of data security. Now, well, how can we enforce that? Some simple measures can be used, which fall in the category of authorization and authentication. So data access can be managed via logins and password that can be assigned to the users. So here, this thing that we mentioned, the access control, it should fall in authorization. Whether you are authorized to read or you are authorized to write, that's authorization. Whereas when we talk about logins and password, that will be authentication. So a user will be authenticated by looking at the login and the password of the user. So here we have it. Each account has its own authorization rules and can be stored in the catalog. Again, a very interesting role of the catalog. So what is it? The authorization information goes into the catalog. Now let's look at some KPIs. What are KPIs? KPI stands for Key Performance Indicators. Now, three KPIs of the database management systems are the response time. The response time denotes the time elapsed between issuing a database request and the successful termination thereof. Fairly simple. Then comes the throughput rate. Throughput rate represents the transactions of the database that are happening per unit time. Okay, so what we want shorter response time. If you hit a query, we want to answer the query as quickly as possible. Response time should be quick or should be less. Throughput rate should be higher. We want to support multiple. We want to support more volume of transactions per unit time. Then comes the space utilization. So space utilization referring to this. Okay, it's very simple actually. Space utilization referring to the space utilized by DBMS to store both the raw and the metadata. So the message is that yeah, database DBMS is doing huge service to us, relieving us about from all the hassles that we'll have to deal with related with the database. But yeah, we don't want to give too much of space to the DBMS, right? So yeah, space utilization is also very, very important. So guys, this again becomes an important topic. Okay, the KPIs, 3 KPIs. Now, one good news is that DBMS comes with various types of utilities which are aimed at improving these KPIs. All right. So the utilities to distribute and optimize data storage, the utilities to tune the indexes for faster query execution, to tune the queries to improve application performance, or to optimize buffer management. All right, so that was it. Let me stop right here, and yeah, good luck. See you next time. Bye bye. Take care.